Okay, so after completing the warm-up, here is the key. Check it out to see what you got. All right, show of hands. This is 6.9. That's a 9, FYI. 928. All right, questions? How are we doing? Is there anything I can address? Who's writing? Okay, I'll give you a couple minutes. It's a pretty short lesson, so it's not like it'll be all right. All right, anybody still doing anything here? Anybody still writing? Tony, you good? Okay, sorry. Just making sure. All right, take out your companions. You're going to turn to page 234. Good? Anybody else? All right. All right, so lines tangent to a circle. Your I can statement, use properties of tangent lines to solve problems. And your new vocabulary is point of tangency and tangent to a circle. So your essential question, how is a tangent line related to the radius of a circle and at the point of tangency? So understand tangents to a circle. A tangent to a circle is a line in the plane of the circle that intersects the circle at exactly one point. So if we looked at this circle, this point P would be the point of intersection. Nothing else touches. And that line PR is a tangent line. That point is called the point of tangency. Pretty simple, right? All right. Now this is what you're going to want to write down in page 234. Page 234, we have a theorem. Again, just add this next to example 1. We're not doing example 1, so you can add it in there. Thank you. If AB is tangent to circle C at P, then AB is perpendicular to CP. Okay, so what they're saying here is this will be perpendicular provided this is tangent. And then the converse of this is going to be if AB is perpendicular to radius CP at P, then AB is tangent to circle C. So if they give you that it's a right angle, then you know it's tangent. So I'm going to give you a minute to write that down. Remember, don't be afraid to go into example 1 because we're not going to be doing example 1. We're going to go straight to 2. And you will need your half sheets for 2. Just an FYI. Okay. Is anybody still working on this? Anybody still? Okay, got it. Gotcha. All right, anybody still writing? Okay. All right, so is KJ tangent to circle P at J? So you're going to want to make a note on this. You're going to use the converse of Pythagorean theorem to check for the right triangles. Now we're on the back of this sheet. You're going to want to hold on to this sheet, okay? We're on the back of that half sheet. So when we use the converse of Pythagorean theorem, remember, that's telling us whether or not we have a right triangle, right? So what I'm going to do here is I'm assuming that that is right, but I have to prove it. So here I have JK is 9 squared plus JP, which is 6 squared, equals 4 plus 6 right here gives us 10 squared. And that's the question mark right there. So we have 81 plus 36 equals 100. Does 81 and 36 add to 100? No. I got 117. Since these are not equal, we do not have a right triangle. So in this case, KJ is not tangent. Anybody still writing? All right. Next one. Segment ST is tangent to circle R. What is the radius of R? So they're asking us to find this. Now, couple things here. First off, this and this whole side is x plus 18. That is the entire hypotenuse. So when I set this up, I'm going to have x squared plus 24 squared equals the quantity x plus 18 squared. Now, it's real tempting to state, hey, this is x squared and 18 squared, right? No. Wah, wah. No. This is x plus 18 times x plus 18. So in order to find that, you need to distribute. I'm going to give you a couple minutes to wrap your head around this and do it. Okay? Go ahead. And then someone can tell me what x is after. All right. Who's got it? What's x equal to? What'd you get? I saw you lip it. 7. Nice job. X is equal to 7. Who needs to see it? Okay. All right. So remember, we're going to have here x squared plus, what's 24 squared? What's 24 squared? Tony? 576. Equals, so this is going to be x squared was a plus 36x, and 18 squared is what? Remind me. 5 something? No, more than that. 3 something. Less than that. Sorry. What was it? 3. What's 18 times 18? What'd you get? 324. Okay. All right, now that we have this, we're going to subtract and solve for x. Now, one thing that's nice is the x squareds are subtracting after each other, so they go bye-bye. I'm going to subtract 324 from this side. What's 576 minus 324? Nobody knows? Nobody knows. Go ahead. What'd you get? 252. And then you divide by 36. So in this case, x is 7. Questions, guys? No? Make sense? Okay. All right, next one. All right, line M is tangent to T and B, and line N is tangent to circle T at C. What is the value of x? All right, well, a couple things we know here. First off, we know these are radii, so those have to be congruent to each other, right? Right. We also know that this side and this side are congruent because remember, when those two meet outside a spot, they're equal, right? Those are congruent to each other. We learned that before spring break. I know it's been a minute, but it's still true. Now for this next part, what we're going to do is we're going to break this circle down right there. And once you know it, this is going to be congruent to itself by that reflexive property. So these two triangles are what? Begins with a C. Say it loud, say it proud. Come on, guys. They're what? Oh, come on. What are they? Begins with a C. Congruent. Shane, they're what? They're what? Okay, they're all congruent, right? So yes, you are going to have to apply those proof rules again. Wah, wah. You thought they were gone. All right, so since everything's congruent, we're going to take that 135 and we're going to divide it by 2 because it is getting split in half. Someone tell me, what's 135 divided by 2? I heard it. Who whispered it? Jackson?
Wow, Tony. 67.5.
Nice job, 67.5. You should be proud of yourself. You got it right. All right, so we know this is 90. This is 67.5. We are going to find this angle right here. So that is going to be 180 minus 90 minus 67.5. What does that give me? Anu? 22.5. And if we need x, because we did technically cut it in half, x is going to equal 2 times that, which gives us a total of 45 degrees. So not too bad, right? Questions on this? Nikki, yes. Yeah, you can apply that rule too. The only reason I did it this way is because you're going to be having to do it in some capacity. That's all. Nothing personal. But yeah, you're right. You could. There's a rule. Any other questions? Okay. Okay, so this one, you try it. Look at this. It says use circle N. Here's the problem though. For some reason, your book says x minus 4 should be x minus 1. Change that to a 1. Change that 4 to a 1. Not our fault. Publishing error. All right, so if we're changing that to a 1, what you guys are going to do is MP tangent to circle N? Explain. So here is MP. We have each degree measure. What is the measure of NMP? What do we got? That one should take us maybe a minute. Tony? It's not Y. What's the measure of that? What's the measure of this angle right here? It's 89. So no, it can't be because the measure of NMP is 89 degrees. It has to be 90 for that to work. All right, if LK is tangent to N, so here's LK, okay? That says at L, so that's your point of tangency. What is Kn? So here's what they're telling you. They're telling you, okay, this is fine. Okay? And you have this x plus 5. You know this is 9 because that's a radius as well. And you know this whole thing right here is going to be x plus 8. So apply your Pythagorean theorem to find x and then find Kn. I'm going to give you a minute to do that on your own. Don't forget, you have to distribute. How we doing, guys? Who's got it? What was Kn? Just do a big reveal. 15. Questions on that? Anybody? No? Nothing? Okie dokie, artichokes. That's it for today. You can get going on your homework. Those of you watching at home, have a great day.